going to be integrating, or we're going to be evaluating this from plus a to minus a. So we just integrating that sine theta function, but we're doing it in terms of x and y. Okay, and so we have y equals plus a, y equals minus a. You're going to get double this because each one of these terms, the minus a here, you're going to be subtracting a negative, and in the denominator it's going to be squared. So you only get one negative here. So it's going to be minus a negative, so that's going to be plus. So it'll be 2k lambda, and then y is a, divided by x squared plus a squared. Now it might be satisfying to see that we get the same infinite result. And so we're done here. This is the expression for finite a. But if we want to make it for infinite a, then what we could do is just divide numerator and denominator by a. If we do that, the a's cancel in the numerator, and in the denominator we get x squared over a squared, and we get a squared over a squared. So now, if you do it this way and you let a go to infinity, you've got to use L'Hopital's rule to figure out how it's going to converge. And then if you do this, then you don't need to do that. You can just see what happens in the limit as a goes to infinity is that this term drops out, and you get 2k lambda over x, which is the same thing we got here. Okay, so we got it both ways. One by looking at it from an xy point of view, and the other one by looking at it from a polar point of view. Any questions? Yeah.
So the expression for the finite a, that's all after using trig substitution, yeah?
Yeah.
Okay.
Yeah. So this is what we got to, and then I got two ways I can go with this. That if I go this way with it, then I'm just taking the sine theta and I'm plugging it back in as y divided by the square root of x squared plus y squared. This is my sine of theta, y divided by square root of x squared plus y squared. And then just evaluating it going. Okay, so I think that I was going to start Gauss's law, but that might be a little much. So I'm going to stop here and let's give you a chance to, oh, one thing that I wanted to talk about with this challenge problem is with the challenge problem, you're going to have x and y components because you take some value for dq, and you're going to get a dE. You're going to get a dE cosine theta, and you're going to get a dE sine theta. Now, because we're not using the symmetry of being in the middle, I can't cancel this out. So I've got two integrals, the integral of dE cosine theta. So we've done this. You just need to change your limits of integration. Instead of going from minus a to plus a, you can go here from y equals 0 to 2a. And you'll get the, basically, I've already done that problem for you. But the dE sine theta part, you'll need to do that by thinking in terms of a, well, you're going to have a, instead of an x over the square root of x squared plus y squared, you're going to have a y divided by the square root of x squared plus y squared. So this is going to just work with a u/du substitution. You don't need a trig sub here. And then when you're all done, you're going to get an electric field, E, that'll be Ex I hat plus Ey j hat. Now I'm not expecting all of this to just completely come together for you in this amount of time. But that's why I want to give you some time today to really work some of these things through, ask a lot of questions, and I'll definitely be signing off the stuff in lab. So I want to take a look at what you've done and see that you're on the right track, so that I'm convinced that you'll be able to do well on the midterm next week. And so don't forget to bring your stuff up to have me sign it off. And we'll have some help today, or we have, and tomorrow. So we've got tutor help in lab as well as here. And so I'll wait to give you the rest of the lab part of this until later. But I've got the answers to these things around here somewhere. So go ahead, you might want to get started on this one. We've got a couple interesting problems. This one is like the one we did last week, but a little more complicated. This one is kind of like that pitfall repulsion problem that we did in lab. This is another one of those constant electric fields between two infinite plates. But be careful here, this is an electron. Okay? It's going to be easy to make a mistake here. You say, oh, well, this is the direction of E, this is the initial velocity, this is going to speed it up. But no, we have electron. Okay? So be careful of that. That's something that very often tricks people up. And then this one is just more of a conceptual question. Do you know what electric field is? Can you tell the difference between the y and the x component? And do you know the difference between electric field and force? All right, so go ahead and